Hello, today I want to discuss potentially unwanted application, or PUA in short, based on bundle installer characteristics. By bundle installer, I mean an application which installs multiple applications. In today's session, we'll discuss the following topics: background for PUA, the current situation, the goals of this presentation, the key players in the PUA market, the suggested solution, the results of our experiment, and we will finalize with a summary of the results and the conclusions of our experiment. Okay, so what is a PUA? A potentially unwanted application usually contains functionality that user wanted, for example, a web browser, but also unwanted functionality like advertisement. It means a PUA is basically an application the user wanted to install, but in addition to the application he wanted to install, additional applications were installed and contained functionality which may be unwanted by the user. Notice the vague name for PUA, potentially unwanted. Okay, what are the risks? The main risk is performance degradation, usually in the web browsing experience, because of the advertisement which is displayed. Other risks can be the loss of privacy, because some of the PUAs are collecting personal data and sending it to external servers. And security, since some PUAs are not allowing security updates in order to avoid antivirus detection. Let's look at some examples for PUAs. One is Shopper Z. Notice that the name is similar to an existing benign application, Shoppers. This application displays web advertisements. My PC Backup. Again, there is a benign application called PC Backup. And again, this utility can create a backup for your PC, but it will also install additional applications which can display advertisements. PC Cleaner. You may be familiar with the benign application CC Cleaner. Again, this application can clean unused registry keys, but will also install additional unwanted applications. Now let's discuss who are the key players in the PUA market. First, we have the advertisers. An advertiser is a person or company that wants to distribute applications. An advertiser can be Yahoo, for example, who wants to advertise Yahoo toolbar. It can be an advertiser can want to distribute a benign application or an application with unwanted functionality like adware. PPI networks. PPI networks are the mediators between application advertisers and publishers. They create the actual bundle installer, the PUA, which will install all the advertiser components. By component, I mean application. Publisher, they are the software application distributors. They will pay for web marketing campaigns in order to attract user to the download site. The download site is also called a landing page. And finally, we have the end users, which are the people who wants to download and install the free applications and end up at the publisher website using advertisement. Now we have a figure which shows the key players. So here, for example, we have several examples for advertiser. Can be Yahoo, can be AVG antivirus, can be Opera browser. And we can see that the connections that the advertiser are linked to the PPA networks. PPA networks work with the publishers. And finally, the installer or the PUA is downloaded to the user endpoint. Notice that in the PUA business, most of the money is received by the publishers since they pay in advance for marketing campaigns and take most of the risk. And the money is paid by the advertisers. Some of this money also goes to the PPA network, which usually gathers the statistics on the PUA installations. And according to these statistics, they charge the publishers for the installation. Okay, let's see what is the current situation. What solutions exist today? So we have several solutions. Antivirus software contain antivirus, contain web rating sites, tools. We have web scanning sites like VirusTotal, which we can upload an application into, and they will let us know if it is safe to use or not. But this solution can be bypassed since benign applications are very similar to PUAs. So how effective are our current solutions? Well, from previous research and from this research, not so much, as the PUAs we downloaded were not detected by the installed antivirus, and offline solutions like VirusTotal does not prevent the PUA installation, and it is not likely that user will upload a file to an external server every time they want to install something. So what is missing? We think what is missing is an effective real-time detecting solution which will prevent the PUA installation without any additional extra effort from the end user. Okay, let's discuss previous work done until today. We have mobile PUA detection. This is based on specific mobile features like jailbreaking and specific mobile requested permissions. This is very different from the features detection which will help distinct the PUA from benign application in Windows or any other non-mobile operation systems. Malware detection. There is a lot of research on this area. It usually either looks for unusual file system usage or static file analysis, suspicious external server communications. These methods will not help with the PUAs, since PUA are very similar to benign applications, so their behavior is not unusual. Another solution from previous research is PUA sandbox detection. This is based on running the PUA in a sandbox by simulation of user interaction to simulate a real installation and see what is installed. This is a very nice solution, but it is not accurate and takes a few minutes for each application. And also it's not a real-time detection, so it's not useful for most users. What are our goals? First, detection. We want to detect the PUA during its installation, not afterhand. Second, prevention. We want to prevent PUA from completing its installation. Third, accuracy. We want to have a low percentage of false negatives and false positives in order to be a solution which user can actually use. So let's discuss our suggested solution. First step is learning. We are collecting features from downloaded applications from many websites, including popular download free application sites, portals. Second, classifying. We will create several classifiers: rotation forest, naive bias, and decision tree. Third is using. We wrote a Windows application code which detects and blocks PUAs based on the classifiers which were created. Okay, let's discuss the features that were used for creating classifiers. 1. Runs as administrator. This means the application requires admin permissions in order to run. Second, number of processes created. This indicates how many processes were created by the application. Third, number of main folders. How many folders were created on the file systems. Fourth, modified kernel drivers. Whether or not the application will modify or create kernel drivers. Fifth, number of imported DLLs. How many DLLs are in the import table. 6, uses IE control. Whether the UI of the PUA uses web browser control. And 7, it is a flag which indicates if one of the imported DLL is OLE-AUT 32, because this is needed for COM framework and is often used by PUAs. Let's discuss our dataset. We have downloaded applications including 96 PUAs and 675 benign applications. Applications sourced were many popular sites, including softonic.com, cnet.com, and filehypo.com. Labeling. Each application was labeled as benign or PUA according to virus total scan, and also by running it manually and checking exactly what it does during its installation. Okay, so let's review the results. For naive bias, for true positive 1, we have false positive rates of 0.02. For false positive 0, we have a true positive of 0.795. For the decision tree, for true positive 1, we have a false positive of 0.005, and for false positive 0, we have a true positive of 0.65, and the best classifier was the rotation forest. For true positive 1, we have false positive of 0.005, and for false positive 0, we have a true positive of 0.2. So here we can see the ROC curve of the rotation forest. As we can see, the results looks very good. Okay, so let's summarize today's presentation. Regarding PUA detection, from our research, it seems that it is possible to differentiate between PUA and benign applications. The research limitations are that it was only done on Windows, and the detection and prevention solution is a POC code. It's not an application we can now distribute and prevent PUA installation worldwide. And what is next? We can continue this research on other OS like macOS, Android, or iOS. Of course, it will need changes in the features. I hope you've enjoyed this presentation and have a nice day.